Hi all, this is Pragya Shrivastava, an educator on Unacademy. Follow me on Unacademy Learning app where you'll find my many more courses. And this lesson is all about settlement analysis. Foundation settlement under loads can be classified into three types. First one, intermediate or elastic settlement denoted by SI. Then we can have consolidation settlement SC, and there is secondary consolidation settlement which we are going to represent it by ST. We have already studied about consolidation settlement in the chapter Consolidation in Soil Mechanics. Let's do some more analysis on settlement. We know that the immediate settlement occurs due to distortions and not because of any volume change in the foundation soil. And this type of settlement actually takes place during or immediately after the construction of the structure. Now come to consolidation settlement. It occurs due to gradual expulsion of water from the voids of the soil. And this secondary consolidation, it occurs after completion of primary settlement over a period of time. And this total settlement S is actually the sum of all these three, SI plus SC plus ST. Now, what are the causes of settlement? First one is underground erosion. Underground erosion may cause formation of cavities in subsoil, which when collapse causes settlement. Then it can be structural collapse of soil. Some soils such as saline or non-cohesive soils like gypsum, silts and clays may occur due to dissolution of materials responsible for intergranular bond of grains. Then there can be thermal changes, can be responsible for the shrinkage in expansive soils, and due to which settlement may occur. Can have frost heave. It occurs if the structure is not founded below the depth of frost penetration. When thaw occurs, foundation may settle down. Then vibrations and shocks cause large settlements, especially in loose cohesion-less soils. There can be mining subsidence, which occurs due to removal of minerals and other materials from the mines below. There can be landslides. Landslides occur on unstable slopes and may result in settlement problems. There can be creep. Creep on clay slopes can also cause settlement. Then changes in the vicinity, like construction of new building near the existing foundation, including induced stresses which may lead to settlement of our structure. Now let's see the loads, design load which we are going to take for our settlement analysis. Loads can be of three types: dead loads, live loads, or it can be a wind or seismic loads. Dead loads, I hope you all know that it is actually the self weight of the structure, and it consists of columns, walls, footings, overlying fills, etc. Then you can have live loads. Live loads depends upon the use of the structure, and these are all given in the IS code books, from where we can take the live loads depending upon the type of structure. Then wind load or seismic loads. Wind load, if it is coming out to be less than 25% of dead load plus live load, we are going to neglect the wind load. But if it is more than 25% of dead load plus live load, the foundation is designed in such a way that the combination of dead load, live load and seismic load does not exceed the allowable bearing capacity by more than 25%. And coarse-grained soils settlement occurs in short time, and it is generally designed for dead load plus live load plus wind load, while in fine-grained soil settlement is designed for permanent loads only. And let me tell you that half of live load is actually considered as dead load, and this for fine grained soil settlement is designed for combination of dead load plus half of live load. Now let's see the immediate settlement of cohesive soils. You have been given a formula for the vertical settlement under uniformly distributed flexible area, and it is given by SI, immediate settlement, is equal to QB 1 minus mu square by ES multiplied by I. What is this Q? Uniformly distributed load. B is the characteristic length of the loaded area. I is your influence factor. Mu, the Poisson's ratio, and it is taken at 0.5 for saturated clays. And you can have ES. What is ES? The modulus of elasticity. And let me tell you that this value 1 minus U square by ES multiplied by I we can get the value of this term directly from the plate load test. Now, if your soil happens to be a cohesion-less soil, in that case, the value of your formula for immediate settlement is given, and it is like this. SI is equal to C1 C2 multiplied by Q bar minus Q. Then sigma, when Z goes from 0 to 2B, IZ upon ES multiplied by delta Z. Now let's see what this indicates actually. C1, C2. C1, C2s are correction factors, and C1, the value of C1 is equal to 1 minus 0.5 Q upon Q bar minus Q, and it is a correction factor for depth of foundation embedment. C2 is actually equal to 1 plus 0.2 log base 10. Then time in years upon 0.1. It is the correction factor for creep in soil. Now, this Q bar, what is Q bar? The pressure at the level of foundation. Q is the surcharge, gamma dF. What is ES? ES being modulus of elasticity, and it is taken to be equal to 766 N. What is N? SPT number, standard penetration test number, and it is actually equal to 2QC. If you are performing static cone penetration test, then QC is the static cone penetration resistance. You can take the value of ES either from the standard penetration test or from static cone penetration test. Now let's see what is IZ. IZ is your strain influence zone. Settlement analysis is actually very important for designing of your foundation, and you must go through this chapter before we start designing of foundations from our next lessons. And till meanwhile, keep studying, stay focused, not that difficult, easy to understand. And in case of any query, you can actually contact me anytime. write to me and I'm always there to answer your queries, and have a nice time.